Yeah, today we are going to discuss about a new topic, that is the logarithm and exponential PO2 mathematics. This is the fact we are discussing today, exponentials and logarithms, right? Okay, so we will go ahead with that. Yes, start with this. If you can't understand any section, please ask. The topic is exponential and logarithm. In this topic, in our PO2 mathematics, we are not much concerning about this exponential part that is available in our A2 level mathematics, but we basically consider about the logarithm, but some part of exponential graphs also should be learned, right? Initially, we should know how to draw the graph of y equals to a to the power x. Right. There are a couple of situations where we can understand is the case one. This is an exceptional case. Case one is where a is equals to 1. That is y equals to 1 to the power x graph. So I'll get a couple of values for the x. I just get -2, -1, 0, 1, and 2. Right. So we can get the y values. If it is -2, 1 to the power -2. So we just should get 1. 1, 1, 1, and 1, right? If you sketch this into a diagram or the graph, you will understand that the shape would be just like this. It's 1, 2, -1, -2. So the graph goes like this way around, which passes to 1. That is the, this is a little bit of exceptional situation than the other a to the power x graph. Other than that, all other graphs are similar. So when you're working out, you'll understand what I'm discussing about. Right? Okay. The next case we are just discussing about for the case of a is equals to 2. Right? So we'll get, that is, we are going to draw y equals to 2 to the power x graph. 2 to the power x graph, right? Okay. Then we will get a couple of information as what it in the previous. X values -2, -1, 0, 1, and 2. Then the y values put it. So if I just make a table, previous one also had to make a table, but I just didn't make any tabular information over here. So if you plot this, you can understand that today here. If this x is 2, sorry, 2, -2, so the answer is 2 to the power -2 is how much? It's turned up to 1 over 4. This is 2 to the power -1 is 1 over 2, 2 to the power 0 is 1, 2, and 4, right? Okay. Then if you plot this graph, if you plot this graph, yeah, I'll get just two couple of graphs in the same diagram. Then I want to explain another fact today. Then I'll get the second case, a is equals to 3. That is y equals to 3 to the power x graph today. So if you just work out x values, -2, -1, 0, 1, and 2, right? Okay. Then if you just draw y equals to 3 to the power -2, it's 1 over 9. 1 over 3, 0, 3, and 9, right? Okay. Then if you sketch this graph, I just draw this. It's like this way around. Then we will try to plot this graph, right? Okay. I just make it a little bit smaller because I want to plot into the same diagram. So I just get them like this. So yeah. I will draw both graphs in the same diagram. That gives you kind of like a, right. This is y and this is x. Then if I get 1, 2, 3, 4, 5, 6, 7, 8, and 9, somewhere over here, right? Okay. Then put the x values 1 and 2. This is minus 1 and minus 2. Okay. Then if you plot the red color one from red over here, I just plot it here. When x equals to minus 2, it's 1 over 4. Put it. It's somewhere over here. Sorry, 1 over 4, somewhere here. This is like little bit of top, and this is 1. If it is 1, it's turned up to 2. Then it's 2, it's turned up to 4. So my drawings won't be much good, but anyway, we'll try to do it in some kind of a nice pattern. So this is the graph of y equals to 2 to the power x. Right? Okay. Then with the meantime, let's try to draw 3 to the power x graph. I used a blue color, same here. It's 1 over 3. So compared to this value, 1 over 3 is some value. Sorry, 1 over 9, it's a very small value over here. This is 1 over 3 is here. So if you plot it properly, this point is common and this is turned up to 3. And this is turned up to 9. Then if you draw this graph, what you can understand is, it's a graph like this. And it goes like this way. This is y equals to 3 to the power x graph. Then what is the basic concepts where we can understand about this graph? The basic idea when you are learning about this graph is, if you just draw y equals to a to the power x graph, you need to understand that the graph is like this. It is all the whatever the a to the power x graph is travels to 0, 1. It's a one common property, travels to 0, 1. And it has a graph somewhere like this, a basic shape of y equals to a to the power x graph. And there's an axis of asymptote y equals to 0, other than that x-axis. X-axis become axis of asymptote, and that is the basic shape of the graph of y equals to a to the power x, right? Okay. So this is the basic shape, and depends on the value. If it is like 2 to the power x and 3 to the power x, the shape is same. But when the value become higher, if the base value become higher, from this graph goes much up. Over here, you can see this property. From here, the graph is, when the value become high, the graph would be high peak. But this side, it goes to the other way around, but it goes down. But this axis of asymptote and the basic shape of the graph remain as it is. Those are the information where we should know about y equals to a to the power x graph. Later on, when I will discuss how to do the transformations of this graph in as a different chapter with the transforming graphs in PO1, I just merge PO1 and do a different session for that. For the moment, you have to understand that this is the basic shape of the graph, right? Okay. So let's move up to the questions where they ask. So those are the facts where we have to know. Yeah, this is the basic shape of the graphs. Later on, we will just come up with this. Okay, right. Now we will come up to, this is the exponential, whatever the shape of the graph, it comes to this way. So that is the way of asking this question. We should know how to draw this, the transformations, right? Okay, yeah. Initially, now let's come up with the little bit of a transformations over here. It's like this. If it is turned up to y equals to, if it is the other one is, if this value is a minus graph, minus a to the power x graph. Actually, sorry, not this a to the power minus x graph, because you cannot draw minus a to the power x graph. You have to draw a to the power minus x graph. Sorry. If you draw a to the power minus x graph, for example, we are talking about y equals to 2 to the power minus x graph. If you draw this, what happened here, this positive x values turn up to negative and negative x values turn out to positive. Therefore, you need to understand is the graph shape would be somewhere like this. So this is the graph of y equals to a to the power minus x graph. This is the y-axis and this is the x-axis. These are the basic information where we should know, right? Okay. Then if you need to draw y equals to a to the power x plus k graph. Another, so this value is does not change as it's 0, 1. If you want to do this transformation, then what happens? This a to the power x graph is this. This is the a to the power x graph. If it is plus k means what happened here? It is like it effect for the y-axis because the total operation where here is another added another value that is k put. So what happened here is now the graph turns to this way. I will just the basic a to the power x graph over here. After that, I'll draw the transformed graph with it. The basic a to the power x graph is like this. So this value is 0, 1. What is the axis of asymptote? Axis of asymptote is y equals to 0. Then if it happens a to the power x plus k, the entire graph shift from k units up. Therefore, this 0, 1 turn up to where? It will travel up to 0, comma 1 plus k. It increases by k units. And this axis of asymptote y equals to 0 turn up to how much? Y equals to k. That is a transformation where we need to know. We know that if it is just like graph of, for example, if I just want to draw some, I'll get some an example and try to explain this. If it is y equals to 2 to the power x plus 3, how do you draw it? Initially, let's try to draw 2 to the power x graph. If I draw 2 to the power x graph, it's a graph somewhere like this. It travels to here, 0, 1, and here the axis of asymptote is y equals to 3. Then what happened with it? Sorry, y equals to 0. I just made a mistake. 0. Then if you turn up into y to the power, sorry, 2 to the power x plus the entire graph shift from 3 units up. Therefore, y equals to 0 turn up to y equals to 3 with it. 0, 1 turn up to 0. It traveled from 4 units, 3 units up, 0, 4. So the graph becomes somewhere like this. Okay. So this is the basic format of drawing the basic graph. So knowing this kind of transformation is sufficient in our AS level, not the everything which is in the first exercise. So you just have a basic idea how to draw it because they have given some kind of extension graphs in PO2 because that is required for our further maths. That is why that part is there. But basically, if you know how to do this kind of transformation, that is sufficient to learn our P2 mathematics, right? Okay. Then we will just, I will just make it by single screens. Then you can, if you want, you can copy down these ones. It's a second page, transformations, yes. So we'll come up to this. Right, okay. Yeah, here. Then we will come up to the next part of it. That is the important topic in our session is the logarithm. Logarithm. Yeah, in this term logarithm, some of, yeah, most of us, we haven't learned this logarithm theories in our IGCSE sessions, but we should know what you mean by this logarithm. First, you have to come up with a notation and try to understand. Notation. Notation is just like this. They have given this kind of a notation. This is logarithm of, this is A and B. So this is called the base. And this is called the value. And this would be, you can say just like type of K. This is the answer. Answer. This notation, first you have to try to read it today, the read of it. How to read it. The way of reading it today, logarithm of B to base A is k. For example, if you write log 10 100, how to read this? This is how to read it. You can say logarithm of 100 to base 10. That's a way of getting this right. Okay. But we need to understand what do you mean by this concept. So what do you mean by this? So you have to understand that log 10 100. What would be the answer? We need to understand what do you mean by logarithm of 100 to base 10. The physical meaning is 100 is which power of 10? Now tell me 100 is which power of 10, Pute? 100 is like if you write the power
No,
of
sir.
tens, it's how much? 100 is 10 to the power what?
2.
10 to the power
2.
2. Yes, great. It's good 2. That's great. Yes. Then we know that log 10, 100, you can say this is 10 to the power 2. Therefore, your answer is how much? 2. That's a simple idea. Other than that, yes, that is the way of getting this, Pute, right? Okay. Then let's go to another one. If I ask you logarithm of 2 to 16. Now, what is the physical meaning of it here, Pute? 16 is 2 to the power what? What is the power of 6? If you write 16 as a power of 2, what will be the answer? 16 is 2 to the power what? 2, 4, 8, 16, 4. Great. That's 4. Good. 4. Then if I write this one, log 3, 27. Now tell me, 27 is which power of 3? 3 to the power what is 27? 3 to the power what? 3 to the power, it's 3. 3 to the power 1 is 3. 3 to the power 2 is 9. 3 to the power 3 is 27. Let's go to another one. If I ask you log 10, this bit, what is this? So 10 to the power 1, 2, 3, 4, 5. So the answer is 5. Understood? Right. Then if I ask you a question like this, log 7, 49. What is that answer? 49 is 7 to the power how much?
2.
2. Answer is 2. Great. Then if I ask you this a little bit of a good question, log 5, 125 is how much? 125 is 5 to the power how much? Log 5, 125 is 5 to the power 5. 5 to the power 1 is 5. 5 to the power 2 is 25. 5 to the power 3 is 125. So the answer is 3. Right. Then this one, log 7, 1. We know that the 1 is, how to write it? You know that 1 is, any term to the power 0 is 1. 7 to the power 0. So the answer is how much? Answer becomes 0. So simply you can write this answer. Right. Then if I ask this question, now let's go over a little bit of a extensions for this graph. So if I ask log 2, 1 over 2, how to get the answer for this? So you can say this is log 2. 1 over 2 you can write 2 to the power minus 1. Then what would be the final answer? The final answer is minus 1. Right. Okay. Then if I ask you log 2, 1 over 8. We know that this is log 2. 1 over 8 is how much? But 8 is 2 to the power 3. Then this is turned up to log 2, 2 to the power minus 3. Then what would be the answer? Answer is minus 3. That is how it comes, right? Great. Then let's go to another one. So if I ask you log 9, sorry, log 3, 1 over 81. Then this one you can say this is log 3. 81 is 3 to the power 4. That is log 3, 3 to the power minus 4. So the answer is minus 4. Right, that's great. Then let's go to another one. If I ask you a question like this, Pute, log 2 square root of 2. Square root of 2 is 2 to the power what? Children? Yes.
Half,
You
sir.
know that? Yeah.
Half,
It's
sir.
yes, it's half. That's great. 2 to the power half. Very good. Then what is the answer, Pute? Answer is half. That's great. Good. Then if I ask you a question like this, Pute, log 3, just like this one. We know that this is fourth root. Fourth root is how much, Pute? 3 to the power 1 over 4. That answer is 1 over 4. Is that clear? Yes. Let's go to another part of it. If I ask a question like this, Pute, log, I'll just make little bit, yeah, complex. 2, they ask about square root of 32. Now you need to make a little bit of a simplification, Pute. 32 is 2 to the power how much? 32 is 2 to the power 2, 4, 8, 16, 32. That is 5. Then square root of 32 is 2 to the power 5. Square root is power half. From the power of power theory, you can write this is 2 to the power 5 over 2. So this answer is log 2, 2 to the power 5 over 2. So what would be the answer then, Pute? Answer is 5 over 2. That's a way of getting this answer. Okay, let's go ahead a little bit further. Right, I'll do another similar question. If I ask you log 3, uh, I will get 81, the cubic root of it. Then it will come up with this. 81 is 3 to the power how much? 3 to the power 4. Then cubic root. What do you mean by cubic root? Cubic root is power 1 over 3. 3 to the power 4 to the power 1 over 3. So that is 3 to the power 4 over 3. So this is log 3, 3 to the power 4 over 3. Answer is 4 over 3. That's a way of doing this question. Right. Okay. Yeah, let's go to another question. I'm making all the advancements of these questions today. This is if I want to get log 2, 1 over square root of 2. So you know that its square root of 2 is 2 to the power half. 1 over square root of 2 is 1 over 2 to the power half. That is 2 to the power minus half. Right? Okay, so you can say this is log 2, 2 to the power minus half. Then what is the answer then, Pute? Answer become minus 1 over 2. That's how it comes. Okay, that's a way of getting this. Right. Let's go to another one, Pute. Then if I ask a question like this, Pute, log 3, 1 over this one. Okay. From here, we just work out this is 3 to the power 4 over 3. Pute. So this is log 3, 1 over 3 to the power 4 over 3. I am referring to this one. That is, this is log 3, 3 to the power minus 4 over 3. So answer is how much? Answer become minus 4 over 3. That is the final answer for this. That's a way of doing this question. Is that clear? Hopefully it's fine. So yeah, then let's go to the another extensions. This is a little bit of a contradictory. If they ask about log 10, 0.00001, right? What is this answer, Pute? So this is 0.00001 means what? 0.040 and 1 means this is 10 to the power minus 5. So this is log 10, 10 to the power 1, 2, 3, 4, 5. Yeah, 10 to the power minus 5. So the answer is minus 5. That's the way of getting this answer. Okay. Yeah, the next one. This is a little bit of a tricky situation. Log 2 over 3 over 4 over 9. What can you say, Pute? We know that 4 over 9, we have to write in power of 2 over 3. So this is 2 to the power 2 over 3 to the power 2. So basically you can say this is 2 over 3 to the power 2. So this one you can write log 2 over 3 times of 2 over 3 to the power 2. So answer become 2 simply. That's a way of getting this answer. Right. The last extension over here is just like this. Log 2 over 3 and this is turned up to 9 over 4. 9 over 4 the reciprocal of it. Therefore, you can say this is log 2 over 3. This is, if you just turn upside down and you can write it as 3 over 2 to the power minus 2. So the answer is minus 2 over here. That's a way of getting this. Since it's reciprocal, when you turn upside down, the power become negative and you can get the answer like this. That's a way of getting this kind of a question. Right. Okay. Right. Okay. Now let's go ahead with the questions in this textbook and see whether what kind of questions they ask. Right. Right. Over here, write each statement as a logarithm. 3 to the power 2 is 9. You write it as a statement of a logarithm. This is, I'm referring to example 3. Which you write as a logarithm. 3 to the power 2 is 9. Therefore, you can write the logarithm term. Logarithm of 3 base 3 9 is equals to 2. That's a simple way of getting this answer. Right. Okay. The next one. 2 to the power 7 is 128. 2 to the power 7 is 128. If you write it as a logarithm, you can say this is logarithm of 2, 128 is a power. Power is 7. That's it. For example, log A B is equals to K means we know that A to the power K is equals to B. That's a fact. We are just referring to when you are answering this question. Put that right. Example 4. Log 381 is for writing as a power. Log 381 is equals to 4. You have write it as a power. How to write as a power? So you can say 81 is equals to 3 to the power 4. That's a simple answer for this. That's a way of doing that kind of a question, right? Okay. So yeah, without using a calculator, find the value for log 381. You already found it. Log 4 0.25. We need to find the value for log 425. Log 4 0.25. We know that 0.25 is what? It's a fraction. 1 over 4. So this is log 4, 4 to the power minus 1. So the answer is minus 1. Simply you can get that answer. Right. Then you can write this one. Log a to the power 5. So see what is the simple answer. Here the power you can write it as an answer. So there's nothing to panic with that, right? Okay. Then yeah, those are the questions where we need to work out. So all of these things we can write it. Okay. Then they mention Pute, without using a calculator, find the value for x. This is another important question where they ask log 5x equals to 4. We have to solve this. Pute. We need to find solve for x. Solve for x. So this is exercise. Others you can do it. 3b question number 4. Exercise 3b question number 4. Right. Okay. The first question is log 5x equals to 4. Log 5x equals to 4. So you can say log 5x equals to 4. So according to this relationship over here, log a b k means a to the power k is b. So you can write 5 to the power 4 is equals to x. So you can get the answer for x, but the x is how much? 5 to the power 4 is 625. That's the answer for that. It's for part A. Part B. Part B solution question is log x 81 equals to 2. Log x 81 is equals to 2. That means you know that x to the power 2, x to the power 2 is equals to 81. Therefore, x equals to square root of 81. That is how much? 9. Right. C. C is log 7 x equals to 1. Log 7 x equals to 1. Then you can say x is equals to 7 to the power 1. That is x is equals to 7. That's the answer for that. Right. Okay. D. Log 2x minus 1 equals to 3. Log 2 x minus 1 is equals to 3. Therefore, you can say x minus 1 is equals to 2 to the power 3. That is x is equals to 8 plus 1, x become 9. E. Log 3, this one also you can do it here. Log this one. Log x 2x equals to 2. Log x 2x equals to 2. F. Log x 2x is equals to 2. So you can say 2x is equals to x to the power 2. So now we have to solve this with it. X squared minus 2x is equals to 0. Therefore, x minus 2 is equals to 0. Therefore, you get the x equals to 0 and x equals to 2. But this is not existing because you cannot write power 0 forms over here. So the answer becomes x equals to 2. It's a way of simple way of doing this question today. Right. Use your calculator to use this logarithm. I'll later on, I will explain how to do this kind of question because using calculator is a different topic. Yeah. Without using calculator, justify why the value for log 250 must be between 5 and 6. Without using a calculator, justify why the value for log 250 between 5 and 6. Log 250. It's question number 2, hopefully. Yeah. Let me see. Yeah, sorry, question number 6. Log 250. Log 250. We need to see whether y this is in between 5 and 6. That's a problem they ask. What do you mean by log 250? So you know that log 250 means 50 is which power of 2? 50 is which power of 2? We know that 2 to the power 5 is how much, Pate? 32. 2 to the power 6 is how much, Pate? 64. Therefore, 50 is a value in between these, Pate. 50 is a value, so you can say 50 is in between 32 and 64, where 2 to the power 5 and 2 to the power 6. Therefore, log 250 remains between where? Between 5 and 6. That's a way of getting this. Right? That's a way answer for question number 6. Right. Okay. Yes. Then question number 7. Find the value for log 2. This is a pretty simple question, so you can get this. Yeah. Explain why log A has the same value for the positive. So you can say log A is a to the power 1 with that A is equals to 1. Find the value for log 1. So log 1 is obviously what happened with it. This is the point you have to understand. If I say log 2 is log 2 to the power 1, answer is 1. So if I say log 3, that is log 3 to the power 1, so the answer is 1. So similarly, if I ask log 2 1, we know that this one you can say log 2 1, you can write 2 to the power 0, so the answer becomes 0. Then if I say log 3 1, you can say this is log 3, this is 3 to the power 0, this one also 0. So like that, whatever the logarithm of 1 becomes 0 for any kind of facts, right? From next session, we'll be discussing how to get the logarithm rules to get for our further simplification.